Hey, we're here at go-to-math.com. Let's click on the calculus button and go down to the first derivative test. We are doing 14-2. Get that to come up. Alright, find where the function is increasing and decreasing, so we want to write that down. We can kind of see here, right, decreasing, then it looks like it's going to be increasing. Alright, so let's write that down and head over to the whiteboard. Okay, so we have f of x is equal to, now I'm going to rewrite this because we're going to be taking the derivative of this, and if there's just a constant in the numerator, it's a whole lot easier to take the derivative this way, taking what's in the denominator and bringing it up. Alright, so we say f prime of x is equal to, bring the negative 2 out front, negative 2 times negative 3 is just 6. We have x minus 2, subtracting 1, that gives us negative 3, and the derivative of 5 is 0. Now let's go ahead and rewrite this with positive exponents. Right. And we have x minus 2 raised to the third power. Alright, so we want to take this thing, set it equal to 0, and find all the critical numbers if there is any. That's the question. So what would make the numerator 0? Well, there's nothing we can plug in. What about down here? So we have a possible critical number at 2, because when we plug 2 in the denominator, we get 0, right? But now remember, for this to be a critical number, it must be in the domain of our original function, and it's not. Because we end up getting 0 in the denominator. Go back here. If I plug 2 in right here, we end up getting 0 in the denominator, and you can't divide by 0. So f is not defined at 2. So that's not a critical number. But what you're going to have to do is, at this asymptote, there's a vertical asymptote at x equals 2. Okay? And we're going to go ahead and put that vertical asymptote down right here. Okay? At x equals 2. And then what we're going to do is pick a test point like 0, and then one to the right of it we'll pick 3. How's that? And so we want to go ahead, and since 0 is in the domain of f of x, or actually and it's also in the domain of f prime of x, right? So we're trying to find where this thing is increasing and decreasing, and if you take 0 and plug it in here, we end up with negative 2 raised to the third power. So we get a negative number in the denominator. So this is actually going to be a negative number. Negative, so we know it's decreasing at 2. And then we'll try out that other test point. Right, plug 3 in, and of course we get a positive number. And so we know that this is going to be a positive number. I don't care what the number is. We just want to know if it's positive or negative. So then it's going to be increasing. Now, take a look at this right here, and I want you to take special note of this, that this doesn't mean there's a minimum, because remember, this is not a critical number. Okay, we're actually testing where the function is increasing and decreasing. Alright, so let's fix our minds on that. Okay, let's fix our minds on that. Alright, so we got let's go back to the web page, app, whatever you want to call it. Alright, and let's go ahead and click on the answer. Okay, so we have decreasing from negative infinity to 2, remember, and increasing from 2 to infinity. Alright, increasing from 2 to infinity. Okay, so watch out for those vertical asymptotes. They're important to look for. Alright, well, we're here at go-to-math.com. You can come on over and practice this stuff, and maybe I'll talk to you there.